Hello everyone. In this session, we will see complete details about active elements. Active elements are basically sources which can produce energy to the external devices. We have mainly two different types of the sources, voltage sources and current sources. These sources can be AC or DC. That means we have a AC voltage source, AC current source. Similarly, we have a DC voltage source and a current sources. As per the supply, the sources can be classified as a AC sources and DC sources. As per the connection, these can be classified as ideal sources and practical sources. As per the performance, these sources can be classified as independent sources and dependent sources. So, in the network analysis subject, you are going to see these many varieties of the sources based on the application, based on the type of analysis that you are doing. Let us see what is the representation of AC and the DC sources. Okay, we have a particular symbolic representations to represent these sources. AC voltage sources are basically represented by the symbol, a circle. Inside there will be a sinusoidal symbol. This symbol is the indication that it is an AC voltage source. DC voltage sources are always represented with the plus and minus polarities inside or outside the circle. Current sources, whether it can be AC or can be a DC, both representation by the same symbol, that is an arrow symbol inside the circle, which indicates that the direction of the current flow. If the direction of the current flow is upward direction, then you will represent the arrow in the upward position. If the current flow is from this direction, if the current flow is from the top to the bottom direction, then you will represent inside the circle in the same way. Now let us see how we can represent ideal and practical sources. Ideal voltage source is the one which will have only the voltage source. The characteristic of the ideal voltage source will be where the voltage remains same throughout the network. That is, how much voltage you apply here. So across the terminals you can see that voltage. There won't be any drop. Practical voltage source representation is an independent source which is connected in series with the resistive element. This is the standard representation for the practical voltage source. Okay, if you see this kind of symbolic representation, it means that it is a practical voltage source. The property of the resistive element is to oppose the current flow. Since this resistor will be keep opposing the current flow, there will be some voltage drop across the resistive element. So the voltage that is going to appear across the terminals will be applied voltage minus the drop across the resistive element. So if you see the practical voltage source characteristics, this dashed line represents the applied voltage Vs. This voltage is actually the voltage which is going to appear across the terminals after certain drop. This is nothing but the drop across the resistive element, that is IR drop. In the same way, we can see the ideal and practical current sources. So for the ideal current source, you will not have any resistive element, and a practical current source, the representation will be always, the ideal current source will be always connected in parallel with the resistive element. Okay. If this kind of representation means it is a practical current source and there will be some drop in the network across this resistive element. Now let us see the most important category of the sources, independent and the dependent sources. Whatever the representations till now you have seen, those are independent sources representations. This is AC voltage and the DC voltage representations, and these are the current representation. Both can be used for either DC or the AC. Dependent sources, main categories are voltage source and current sources only. But based on which parameters these sources depend have been expanded to 4 types. That is, the voltage source which depends on the voltage value, voltage source which depends on the current value, and the current source which depends on the voltage value, current source which depends on the current value. Let us see in detail about these dependent sources. You can easily identify which type of source it is, whether it is a voltage source or whether it is a current source, based on the symbol that is represented inside this symbol. And the major difference between the independent and the dependent sources is, independent sources will be always represented by the circle shape, but the dependent sources will be always represented by a diamond shape. If inside this diamond symbol, if polarities are given, it means that it is a voltage source. Whatever the value it is represented next to this particular symbol, whether it is a current or whether it is a voltage, but this fall into the category of a voltage source. If the arrow is represented inside the diamond symbol, it means that these are the current sources by default. Now let us see the representations: voltage, current, voltage and current. So if the voltage is represented next to the source symbol, it means that it is a voltage dependent voltage source. This is current dependent voltage source, voltage dependent current source and current dependent voltage source. So here what is the problem is, this is a voltage source, this is a voltage source, this is a current source, this is a current source. Okay. So voltage source value should be in volts, not in currents. Current source value should be in currents, not in terms of voltage. That means these two sources are in correct representation. So voltage source, its value is in volts. Current source, its value is in current. But here these two are mismatching. Okay, this is a voltage source but we have given a current representation. This is a current source but we have given a voltage representation. Then what we have to do? So it should be in terms of current, but that should be equal to a voltage. That's what we are supposed to do. Because the voltage source should have the voltage value but in terms of the current. So what we have to do, with what value we have to multiply or divide such that the current will be equal to the voltage. Means we know that with respect to the Ohm's law, we have R into I is equal to the voltage. That means if you multiply resistive element with respect to this current, that will be equal to the voltage, but which is represented in terms of the current. Similarly, it should be a current value which is represented as a function of the voltage. Means the value should be in terms of voltage, but it is not a voltage. It should be a current value. So again we are taking the help of the Ohm's law. So we know the V is equal to IR, but I want to represent my current in terms of the voltage. So let me send this value to this side. That becomes I is equal to V by R. So this can be written as 1 by R into voltage V. This reciprocal of resistance is called as conductance G. Okay. So always we have a relation that the reciprocal of resistance is equal to conductance G, that is G into V. So with this multiplications, we are going to represent the dependent values. That means on which values these sources are depends. So these two values we have replaced. That means now this value is a voltage, but it is represented in terms of the current. That's what people should understand. So often they confuse that. Suppose if I have represented here 2 into I, 2I, students first think that it is a current source because here I is given. But here importance should not be given to the value, importance should be given to the source. If this is a voltage source, this value is also a voltage, but given in terms of the current. Means this 2 is nothing but the resistive value it is. Okay, resistance into current is nothing but voltage. That means this value is a voltage, not the current. Similarly, if you give some 5V here, so as soon as we see, our focus will be like it is 5 volts, it is a voltage source. So people assume that it's a voltage source and they start doing the analysis. So there it is, the entire problem goes wrong. So here it means that this 5 is nothing but the conductance, the G into V is nothing but the current. That means it is a current value represented in terms of the voltage. So should be very cautious while working with the dependent sources especially. Now what about these things? To make it uniform, okay, so to bring the uniformity across the representations of the dependent sources, so we are bringing some constants here also, okay. Those will not have any meaning to it, it is just a constant value. So we are replacing the V by alpha into V and we are replacing the current by beta into I, okay. So where alpha and beta are the just constants, but here R is the resistive element, G is the conductance, okay. Let us give what are these alpha, R, G, beta and values represents, where alpha and beta are the constants, R is the resistive element in ohms and G is the conductance. The unit for the conductance is mho or Siemens. This is all about the dependent sources. I hope it is clear. Thank you.